All right, so question 130. Alan's teammate Scott was also working on the problem 129, but he organized his table differently. As Scott explained his table to Alan, he used pattern in the first two trials to represent the quantities in the third row with a variable of x. So look down at this table. So here's my table down here, get myself out of the way. And the length, I think, is what I'm guessing at. And then it looks like in all of these, we took this length and we multiplied it by 2, and then we always added a 3. So now it looks like in order to find the width, I'm going to double the length and add 3, because I think that's what happens on all these. So I doubled the length, I add 3. I double the length, and then I add 3. This time they're saying I don't know what the length is, but I'm still going to double it. So 2 times x, and I add 3. So now I know how to get my width. All right, so part A. How is it different from Alan's table? Well, in Alan's table, I had no idea how to get the width, if you remember correctly from the last video. Now I do, because he kind of wrote it out and showed me how he got it. So I know I'm going to double the length and then add 3. And also, I would just say that he kind of did a better job of kind of showing his work. What does the x represent in the table? So this x is going to be my length. This is what I am guessing for the length every time. So x just represents length. Part C. In words, describe the relationship between the length and the width. So the relationship between the length and the width is I'm going to double the length. So every time we took 2 times the length in each of these. So I'm going to double the length and add 3. So in words, you should be writing that out, that you doubled the length and then you added 3. Or you times the length by 2 and added 3. Where did the expression x plus 2x plus 3 plus 2x plus 3 come from? Explain your thinking. So that's this piece down here is what they are talking about. Okay, so where did that come from? Well, it's under the do, which is adding up all 4 sides. So I think that x is a length. So I think that that's one of the lengths of ours. So if we had a rectangle, all right, I think that that is one of our lengths. And then this x is another length. And then I think that this 2x plus 3 is one of our widths, because remember it said that we took the length, we doubled it, and then we added 3. So that would be one of the widths. And then this is the other width, where we took the length, we doubled it, and we added 3. So where did this expression come from? It came from adding up all 4 sides of our diagram. So here you notice it's 3 plus 3, because it's a length and a length, and then 9 and 9, a width and a width if you do this math. 2 times 3 is 6, plus 3 is 9. So this here became a 9. So we've got 2 lengths, 2 widths. Here, 2 times 6, or the 6 first is my length, so that's a length, that's a length. And then these 15s are from here. 2 times 6 is 12, plus 3 is 15, so that's a width, and that's a width. So this came from my adding my different sides of my rectangle together.